therefore you get your optimum thickness T equals to R1 or K over H minus R1. Okay? Yeah, so far so good? Everybody's happy? Now, do you see something weird here now in this result? So, of course, so for this, now T obviously has to be positive, right? If T has to be positive, then what must be the case? K over H must be larger than R1. So that means we are looking at pipes whose radius is smaller than K over H. So if the radius of the pipe is larger than this number, there is no optimum thickness. What it means is that you increase the thickness, your total heat loss will go down. Does that make sense? So there is no optimum. You increase thickness, heat loss will go down. So if R1 is larger than this, then the answer is, if you want to maximize your, minimize your heat loss, maximize your thickness. Now, of course, there is going to be a secondary optimization coming from the cost optimization, which we'll do next time. But at least from the perspective of heat loss optimization, the answer is increase thickness. But let's consider the case where R1 is actually less than K over H. If R1 is less than K over H, then this T, basically T star. So that means there is one optimum. So that means the thickness, the rest of this is heat loss, or this is like T, heat loss. So at some solution, the question is this heat loss a maximum or a minimum? Now, of course, we can take the second derivative or convince ourselves, but we know physically that if thickness goes to infinity, what do you think will happen to heat loss? It will go to 0. So therefore, you know it cannot be a minimum, because if it's a minimum, you know if it's a minimum, the trend has to be like this. At infinity, it has to go to infinity, which is obviously not the case. So on physical basis, you know that this must represent a maximum. So that means the heat loss actually has a maximum. So in this range, in this particular range, if you increase thickness, your heat loss actually increases till you overcome the critical one, and of course it starts to go down. Right? Interesting? The reason for that, of course, is the curvature. Because as thickness increases, the radius is increasing, so the surface area is increasing, right? Okay, but now let's calculate this value K over H. So what is this K over H? So let's calculate this number K over H. Now this K is K of what? No. Insulator, right? This H is the heat transfer coefficient where? Air. Now how do you estimate heat transfer coefficients?
K over delta.
Very good. K over delta, right? Sorry, what did you say? 1? Only 1 except you have to worry about with it. Alright, so this basically becomes K for the insulator divided by K for air times delta, right? Now delta, what would be delta? What would boundary layer thickness be in air? Sorry, depends on what? Very good, depends on the degree of convection. But take a rough number. If for a pipe that's of the order of a meter, the boundary layer thickness will probably be a centimeter at most, or even smaller, especially if there's convection. Okay? And this K, what was the ratio of K insulator over K air? Do you think it will be larger than 1 or less than 1? It will be larger than 1?
Much less than 1.
It will largely be smaller than 1, right? Because if it's a good insulator, it must have very low. So this number will turn out to be of the order of a millimeter or so. Which means it is completely irrelevant when you're talking about big pipes in big industry. However, can you give me an example where it might become relevant? Something like small wires, right? Electrical, small wires, and so it may have some relevance in completely different fields like electrical engineering where diameters are completely different. However, in that case, losing heat is not the most important problem anyway. So anyway, the bottom line is that mathematically it's a very interesting problem, that's why I did it. But in terms of reality, you never run into this problem, at least chemical engineering. Okay? Which you might be thinking, why did you do it? Yeah? answer? It's interesting, exactly. At the end of the day, that's what our life is all about, right? Interesting. Which actually brings me to an interesting question, which you can think about. What does it mean when something is interesting? I have my definition for it. There's no right answer or wrong answer to this question. But you can just ask yourself, what does it mean interesting? We all use the word like 10 times every day. This is interesting, this is not interesting. What is interesting? I don't want an answer because it's going to be a long discussion. You can stay after the class and give me an answer. But anyway, so yeah, that's it. That's all I have for today. So enjoy your weekend.